Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 3C and Mathematics 4, Swedish high school education system. Hi, this is Babak. In this video, I'm going to solve the following problem for you. This is a problem on the topic of tangent line. Let me read the problem for you first. Determine an equation for the tangent line from the point A with coordinates 1 and minus 2 to the graph of the function f of x equals to 2x squared minus 3x plus 1. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, you will get two tangent lines. The equations for those tangent lines are y equals to minus 3x plus 1 and y equals to 5x minus 7. Okay, now let us solve the problem. I will solve this problem in two different ways for you. One using the notion of derivative and one without using the notion of derivative at all. First, let me use the method of using derivative. Method 1. Using derivative. Okay, so the problem here is that this point does not lie on the graph of this function. You can immediately check that. Why is that? Because if I calculate f of 1, then the answer becomes 2 times 1 squared minus 3 times 1 plus 1. But this answer is 2 minus 3 plus 1, which is 0. But here, the y coordinate is minus 2, and it is not equal to minus 2. So this means that the point A does not lie on the graph of f. Okay, so the method that we learned so far is not working here. So because if you want to find an equation for the tangent line, the first thing that you need to do is to find the slope of the tangent line. But you know that, so let me just draw some graph for you here. So you know that from your lesson that if I have a graph, for example, if that's the graph of the function f of x, any function, and then if you know the x coordinate of the point at which you want to draw the tangent line, then if you want to find the slope of this tangent line, you take the derivative of your function and then calculate it at the x coordinate of the point of tangency. Okay? But then, if this point is not the point of tangency, if this point is somewhere outside, you cannot use this method to find the slope of the function, a slope of the tangent line. Yes, because this formula only works if you take the derivative and replace the x with the x coordinate of the point of tangency. In that case, this will give you the slope of the tangent line. But what happens if I have something outside? Okay, so let me just draw another diagram for you. So for example, assume that I am facing this situation, that this is the, for example, the curve, this is the graph of my function, but my point lies somewhere outside. This is my point A, and this is no longer the point of tangency. And I want to do the same thing. I want to draw a tangent line that passes through A, okay? And of course, it would be tangent to my graph at some other point, okay? And then you see that the coordinates of this point outside the curve is given. So I cannot take the derivative of my function and replace the x value with 1 to get the slope of the tangent line, because I need to know the x coordinate of the point of tangency. Okay, so how can we do that? You can pretend that this is the graph of this function. Of course, this is far from reality, but it doesn't matter. So what you do in the first method, you say that, okay, I can pretend that I know this point of tangency, that I will call it t. How do I pretend? I would say that, okay, let us consider the point of tangency is a. Okay? And of course now, because this point lies on the graph, the y-coordinate would be f of a. Yes? But what is f of a? F of a means the same expression you see here, that you have to replace x with a everywhere. So this means that the y-coordinate of the point of tangency would be this. Yes? Okay, now if I ask you, can you find the slope of the tangent line? Of course, you can do something, because what you do, you take the derivative of your function, which becomes 4x minus 3. And then if I ask you what is the slope of the tangent line, you would say that I will replace the x in the derivative with the x-coordinate of the point of tangency. Even though it is not clear what is that a, let me just write it like this. So that would be the x-coordinate of the point of tangency. Okay? And now I want to write an equation for this line, even though still I don't know exactly what k is, but I know that this has this relation. Okay, so you know that an equation for the line that passes through a point with coordinates, let me write it with a different color. If you know a point on your line, and if you know the slope of the line, then if you want to write an equation of that line that passes through this point with the slope k, that is y minus y naught equals to k times x minus x naught. Yes? So I want to use this to write an equation for the tangent line. So what I do, I would write y minus y naught, but y naught is this point, which is 2a squared minus 3a plus 1 is equal to k, which is 4a minus 3, times x minus a. So I am actually completely momentarily forgetting about this point. I'm pretending that I have this point of tangency, and I am writing everything based on the information that I have here. Of course, I cannot say that this is an equation for the tangent line, because if you ask me what a is, I don't know yet. So it means that my goal is now to find this value for a. But how can I find that? Oh, okay, I know that this tangent line is supposed to pass through this point. So it means that the coordinates of the point A should satisfy the equation of the tangent line. So it means that if instead of x, I put the x coordinate of my point A, and instead of the y value, I replace the y value here, this should be a correct equation. Okay, so I will do this. I replace y with minus 2, and then of course here I can multiply this negative sign inside, so it becomes negative 2a squared plus 3a, negative 1. On the right hand side I have 4a minus 3, and I replace x here with the x coordinate. So you need to know why we can do this, because this line is supposed to pass through this point. So then what happens? This becomes x, which is 1 minus a. And now if I ask you what is not known here, there is only one unknown in this equation, and that is a. So it means that I can solve for a. When a is found, I put it back into this equation. Then I get an equation for y and x, which would be my solutions to the problem. Okay, so I will concentrate now to solve this equation. So on the left hand side I can simplify a little bit, so it is minus 2a squared plus 3a, and then I have minus 3. On the right hand side I just simply multiply, so it becomes 4a minus 4a squared minus 3 plus 3a. Now what happens if I move 3a to the left? This will cancel that one. If I move minus 3 to the left, it will cancel that one. So I move 4a squared minus 4a squared to the right, it becomes positive 4a squared, and then negative 2a squared becomes positive 2a squared. And then finally I move 4a to the left, it becomes minus 4a equals to 0. And this is a quadratic equation which is very easy to solve. I just factor 2a out, it becomes a minus 2 equals to 0, and I will get two answers. Either a is equal to 0 or a is equal to 2. Of course, this is not asked, it is not demanded in the problem. If you want now, you can find the point of tangency as well. So for example, if you put a equal to 0 here, it means that a point, you have 0 and 1. So 0 and 1 is one of the points of tangency. And then if you put a equal to 2, it means that there is another point of tangency. So when there are 2 points of tangency, it means that there are 2 tangent lines. Okay? But what I need to do, I need to write this, for example, let me put a star here. Now, if a is equal to 0, using a star, I can conclude that I have y minus, I am replacing 0 for a everywhere. So this is gone, it becomes positive 1 minus 1, so it becomes y minus 1. On the right hand side, I will have minus 3 x minus 0. So you see that I immediately get one of these answers, which is minus 3x plus 1. So this is one of the equations of those tangent lines for that graph. If you don't see it here, because I haven't drawn this carefully, I will go to GeoGebra and show that this is indeed the case. So this is one of these equations that we have. And now if I put a equal to 2, using again the same equation, star, let me simplify this one as well. So this becomes a y. If I put 2 here, it becomes 8 minus 6 plus 1. So it becomes positive 3, but I have a negative sign here. So it becomes a negative 3. And on the right hand side, it becomes 4 times 2, 8, minus 3, 5. And then I have x minus 2. And if I simplify that, it becomes 5x minus 10, and I moved minus 3 here, so it becomes minus 7. So you see that I have 2 equations of my tangent lines, and these are exactly the ones given in the answer to this problem. So this is one way of solving this problem, which I use the notion of derivative, but in a wise way. So the only point that you need to be careful, here in this problem, you are not allowed to take the derivative and replace the x value with 1 to get the k value, because this point is not the point of tangency. How do I know that? I check the coordinates of the point in the equation of the function. I realize that this does not satisfy the equation of the function, and it means that this is not lying on the graph. When it does not lie on the graph, it cannot be a point of tangency. Okay? Okay, but now there is also another way to solve this problem. So let me go to the other page. Another way is that, of course, you know that this is a parabola. You don't need to be very careful in drawing the picture, but you know that this is a parabola. Yeah? So let me just sketch something for myself. So this is a parabola with a minimum, and then you realize that this point is not on the graph, so let us pretend that this point is somewhere here, okay? And then you know that there are infinitely many lines passing through this point, yes? So for example, if I concentrate on this line, this cannot be the tangent line. It doesn't intersect the graph at all. It might happen that I have this case that it will go, so let me, for example, let me just draw this point in a way that it is easier to see what's going on. So let us pretend that A is here. So there are infinitely many points, infinitely many lines passing through here. So some of these lines will intersect the graph at 2 points. Okay, so they cannot be tangent. So any line that passes through A but intersects the parabola in more than one point, it cannot be a tangent line. Okay, if it doesn't intersect it at all, again it is not a tangent line. So if I want to find a tangent line, it means that from all these infinitely many lines passing through A, I need to concentrate and find those, if any, that intersect the parabola in exactly one point. So, and then needless to say, if that is possible, then it means that that line is the tangent line. Okay, so what does it mean? It means that, let us say that, of course, we don't know the tangent line, the slope of the tangent line, so let us pretend that that slope is k. And let us concentrate on finding the equation of all possible lines that pass through this point A. The coordinates of the point is given, so it is 1 and minus 2. So assume that you want to write an equation of this line whose slope we pretend to know, and it is k, and the point is this one. So again, according to that formula, y minus y naught equals to k times x minus x naught. We can just write an equation for those lines. So it becomes minus 2, k, we pretend to know it, x minus 1. So if I simplify that, it becomes kx minus k. What I am doing, I am multiplying this k. This becomes positive 2. I move it to the other side, it becomes negative 2. And then I set up a system of equations. One equation is the equation of the graph. Another equation is the equation of this line. Of course, this is not one line. This is an equation for infinitely many lines, but all of them are passing through this point. Now, I am looking for the intersection points between these two figures, these two shapes. Yes, one of them the parabola, the other one the straight line. So it means that I can equate the y value. So then it becomes 2x squared minus 3x plus 1 is equal to kx minus k minus 2. If I ask you, if I solve this quadratic equation and find the x, what are these x's? You would say that these x's are the x coordinates of the intersection points between this line and this parabola. And you know that, so you see that this is a quadratic equation, and you know that for a quadratic equation there are three possibilities. Either we do not have any solution at all, so it means that that line corresponding to that particular value does not intersect the parabola at all, and it cannot be a tangent line, of course. Or there are two solutions. It means that the line that passes through the point A intersects the graph of the graph of the function, namely this parabola at 2 points. Again, this cannot be the tangent line. So it means that I am only interested in one particular case for which this equation has a solution, but has exactly one solution. So it means that I have to force this equation to have exactly one solution. How can I do that? It's simple. I just arrange it in a standard quadratic form. By standard, I mean I move everything to the left. So it becomes minus kx plus k plus 2 is equal to 0. It's not standard yet. Standard means that I have to have one quadratic term, and then between these two I can factor a negative x out. So it becomes negative k plus 3x. And then I will have k and then plus 3 as my constant term. So this is my quadratic equation. But I want to force this quadratic equation to have exactly one solution. So it means that the discriminant of this should be equal to 0. Yes? So what is the discriminant here? Delta is b squared minus 4ac should be equal to 0. So this means that k plus 3 to power 2, because negative k plus 3 is b, to the power of 2 negative sign is gone. And then minus 4 times a times c, minus 4 times a is minus 8, times k plus 3, this is equal to 0. Okay, of course, if I want to solve this, I can raise it to power 2, but I can immediately see that I can do better. Yes, I can factor a k plus 3 out to solve this equation. I factor a k plus 3 out, and then from here a k plus 3 is left, and from here a minus 8 is left, so it becomes k minus 5 equals to 0, and this gives me k is equal to minus 3. Yes, and the other one, k is equal to 5. These are two answers. Okay, so it means that I found again two answers for y. So there are two lines, not one line, with different slopes. Okay, now I am asking you the equation for the tangent line. This was the equation of all possible lines that passes through this, but I fine-tune k in a way that the line is tangent to this one. So now if I want to find the tangent line, so let me now call this double star. And now I would say that if k is equal to minus 3, using this double star, I can immediately find the equation of the tangent line. So it is y equals to, instead of k, I put minus 3, so it becomes minus 3x. And instead of k, I put minus 3, it becomes positive 3 minus 2 is positive 1. So it is positive 1, and you see that this is again this correct answer. And then if k is equal to 5, what happens again, I use the double star again, and then I will find another equation. So y becomes equal to, instead of k I put 5, so it becomes 5x minus 7. Yes, so this is also another one. So you see that in this way of solving the problem, I actually didn't use the notion of derivative at all. Okay, so you need to understand why this was working. Okay, so I think it would be interesting if we can see these problems, the graph of these things that we got using GeoGebra to have a better understanding of what's going on. Okay, so let me just write these things down. So I have these two. Okay, so now let me just go to the, so what I want to do, I want to draw the graph of this function and highlight this point and draw the graph of these lines to see that what we have done is perfectly correct. Okay, so we go to the GeoGebra. Here I just type the function, so which is 2x to the power of 2, then minus 3x plus 1. So that what you see is the parabola here. And then I want to type the coordinates of the point A, which is 1 and minus 2. And this, you see, this is highlighted here. So this is the point A. And now, so if I want to show the label, so yeah, so I can just say that, okay, show the label. So you see this is point A. And now I will draw the graph of those lines that we found. So one of them was y equals to minus 3x plus 1. And so you see immediately this is passing through the point A, and it is tangent exactly to the parabola. So I can probably change the color so that you can see it better. So this is one of those lines that is passing through the point A and tangent to this parabola, and the other line that we got, it is y equals to 5x minus 7, and you see this is again passing through this one. Let me also change the color here to another color, for example blue. So you see that both of those lines that we got are completely correct. They are not only passing through the point A, but they are also tangent to the parabola. Yes. Okay. So I hope that this video has been useful for you. I will put the PDF file, the link to the PDF file of the solution below this video. Until the next video, be safe and goodbye.